Alright, Stretching and Shrinking Investigation 4, page 48, number 5 in the ACE questions. Alright, again it tells us the rectangles below are similar. So G is similar to H. So 3 times something is 5, and whatever that something is, 4 times that same something is going to give us X. And A is asking us what is the value of X. Alright, number 5 is also going to involve fractions. Hopefully you're starting to pick up on the fact now that 3 times, and when it's a fraction to get this number over here, all you have to do is take this number and put it over that one. So 3 times 5/3 is going to give us 5. So now all we got to do is use that fact to figure out X. So 4 times 5/3 is going to give us X. So we got to figure that out on paper. Alright, so on our homework here, we'll put 4 times 5/3 equals, and then we'll figure it out, we'll solve for it. I put the 4 over the 1, for those of you that still aren't comfortable leaving it out. You should really not have to use this now, but again, if you need to, it's okay. So 4 times 5 is going to give us 20, and 1 times 3 is going to give us 3, so we're left with 20/3. And if we reduce that improper fraction, we're left with 6 and 2/3. So what that means is X is 6 and 2/3. B is what is the scale factor from G to H. Hopefully you've also realized by now that we've been answering this question first every time and using it to get this and then just reiterating it here. So 3 times 5/3 is 5, so the scale factor from G to H is 5/3. And it is actually okay to leave it improper when you're just talking about scale factor. Since we used it to multiply anyway, it's not a big deal to leave it that way. Alright, C says find the area of each triangle. Let's do G, the easy one, first, since both of the numbers are there. Length times width, so 3 times 4, the area of rectangle G is 12. Alright, so we got G, now we have to find the area of rectangle H. Again, I'm going to show you both ways. And another reason why I'm doing this is, yes, I want you to get in the habit of using the scale factor method, but you could always use the traditional method to double check your work as well. So we have 5, which is one of the sides right here, times 6 and 2/3, which we found out was the other side. Now, to make things easier to multiply, we're going to change it back to improper, which is 20/3. So 5 times 20/3, again, I put it over 1 to help you out, is 100 over 3, which is the same thing as 33 1/3. Okay, I put my answer there because we know it's 33 1/3, but now we want to use the scale factor method, which is the original area, and the original area was 12 times the scale factor squared. The scale factor was 5/3 from here to here. So we have original area times scale factor squared is going to give us the area of H. So 5/3 squared, 5 times 5 is 25, 3 times 3 is 9, so it's 12 times 25/9, and that's what we're going to use to get our answer. So we get 300 over 9 as an improper, and now we have to reduce that. And as it should, it comes out to 33 1/3, so we use the 7th grade method, original area times scale factor squared, and we got 33 1/3 for the area of rectangle H. Alright, for D, it says, what is the relationship of the area of rectangle G to the area of rectangle H? Well, G is smaller than H. So the scale factor from H to G is 3/5. So if we square the scale factor, 3/5 squared is 9/25. So G is 9/25 the size of H. And if that seems weird to you, all you got to do is multiply 33 1/3 by 9/25, and you're going to get 12. So G is 9/25ths the size of h, meaning it's smaller than h. All right, we've just finished number 5 for investigation 4 of stretching and shrinking on page 48.